Hello students, in this video we'll see how to solve the transport equation in general. If I'm given a constant b, so b is just any real number, and a function f of x and t with f of x0 f of x0 known. So in other words, I know the value of this function at time 0. So for completeness, we're going to call, let's call it like this, let's call f of x0. This is just a function of x. There's no t's in this. I'm just going to call this function g of x. This is going to be called my initial data. This is my initial data or initial profile. Okay. What we're going to do is we're going to consider the transport equation. Consider ft, the t derivative of this function, is equal to b times fx, which we can rewrite in the following way. We can write this as ft minus b fx is equal to 0. Okay? In a previous video, we saw that a change of variables along with the chain rule was able to help us solve this problem. So let's do the same sort of procedure over here. So what we're going to do is we're going to consider a change of variables. Let's consider a change of variables. We'll consider xc is equal to what? Xc is equal to, let's say it's going to be equal to t minus bx, and eta is going to be bt plus x. So I'm going to consider this change of coordinates. And the reason I'm going to consider this change of coordinates will become evident when I think about directional derivatives and the direction in which this is saying that this is, in some sense, is saying some directional derivative is equal to 0. So I'm using the fact that this is really a directional derivative on the left-hand side being equal to 0. So I'm going to align the direction of that directional derivative with one of the new axes. So I'm going to use the chain rule now. So what is partial f partial t, for example? So partial f partial t. Partial f partial t is partial f partial xc. Then partial xc with respect to t, that's going to be a 1. And then plus partial f partial eta. And then partial eta partial t. Partial eta partial t is going to be b. And then we can look at partial f partial x. Partial f partial x will be what? Partial f partial xc. Then partial xc partial x, which is negative b. And then I'll have a plus partial f partial eta. And then partial eta partial x, which is just going to be a 1. So now what I'm going to do is I'm going to multiply the top equation, partial f partial x, or the bottom equation rather, with respect to b. So if we multiply the bottom equation with respect to, let's do actually negative b, because I want to see a negative b. So let's take this equation over here and multiply by negative b. And that will turn into what? That will turn into f xc for the xc partial derivative times b squared. And then negative b f eta. So now, this of course is just what? This is just f xc plus b f eta. Okay? Now if we take ft and add it to negative fx, we're going to basically just add these results down over here. So we'll have this term over here plus this term over here. We see the f etas cancel out, and what will we have? We will have that. We'll have a b squared plus 1, so we're going to have 1 plus b squared, and then f xc is equal to 0. Now 1 plus b squared is not 0 because this is greater than 1, greater than or equal to 1 for any real number. And so that tells me that f xc is equal to 0. So my function as a function of xc and eta tells me that there's no xc dependence, which means you have to be a function of what? You have to be a function of eta. So f of xc and eta is just some function which we don't know yet, c, only depending on eta. So in other words, what we have is the following. We have that f, hence f of x and t is some function c of what? C of eta, and eta is x plus bt plus bt. Now, of course, if I plug in t equals 0, what am I going to get? If I plug in t equals 0 to this equation, I have that f of x0 is just going to be c of x. But we know that that's equal to g, our initial data. So that's going to be g of x. So that c is really g. So my function f of xt is going to be equal to g of x plus bt. And so in a real way, what we see is we see that I take my initial profile, g of x, and what am I doing to it? I'm shifting it over to the left by what? By bt units. So in other words, the solution takes the initial profile, and as time moves on, it just shifts that initial profile to the left. So I'm really transporting my initial profile in a direction that with a corresponding velocity. The velocity corresponds to what? The velocity corresponds to that constant b. So whatever the b is, based on its sign, it's either going to go right or left based on the sign of b, but I'm taking that initial profile and I'm simply just transporting it in time. That's why it's called the transport equation. Thank you very much.